Students, now that we have understood all the standard formulas, the formulas for all the standard functions, we can say, we are in a position to begin with the examples. Now, if you look at the examples which are written on the board, you can see that they are all algebraic expressions. So that's the very first type of questions we are going to see, where algebraic expressions will be involved. Now, there are many different types within the algebraic expressions. This is the very first type. Here, you can observe that the power of the numerator in any of these expressions is always less than the power of the denominator. Observe carefully. Here it is x cube. So power of the denominator is 3 and the power of the numerator is 2. So in type 1, we are going to see examples where the power of the numerator is always less than the power of the denominator. So students, when this happens, when you see that the power of numerator, so power of the numerator is less than the power of the denominator. Whenever you see that the power of the numerator is less than the power of the denominator, you should always proceed with the method of partial fraction. So here, students, I'm going to make use of the method of partial fraction. So let's understand what this method is. You have already learned this method in your lower standards. So it is going to be a small revision for you. So let's begin with one of the questions from here. Let's take the third example. So students, either I solve the third example or I solve first or second or any the fourth example. Any of the examples you take, the procedure is exactly going to be remaining the same. So let's begin with the third example over here. Now, if you observe the denominator here, you are given a cubic expression. You are given a cubic expression here as well. Here also, if you try to multiply these factors, you will be getting a cubic expression. So for partial fractions, look at the word that is used, partial. That means some part, and then you have fractions. So you need to take fraction over here. So it does not matter what the numerator is. Either it can be a constant or it can be a term whose power is less than the power of the denominator. This is very important, students. You should always have terms in the numerator where the power is less than the denominator. Observe here 2. So one might think, what is 2? 2 is a constant. So can I say 2 is actually 2 into x raised to 0, because x raised to 0 is going to become 1. So here also you can observe that the power of the numerator has become less than the power of the denominator. So whenever this happens, you can definitely proceed by something called as the method of partial fraction. So here I'm going to make use of the method of partial fraction. So let's take third example. Now, as I said, you can have this cubic expression and you need to factorize the cubic expression. You want to get the factors. Only then you can proceed for partial fraction. So let's see how to get the factors of the cubic expression. Now students, again you have learned this in your lower standards, something called as the synthetic division. I'm going to make use of the synthetic division to simplify this particular cubic equation. Now it is a very simple task, students. What you do is, whatever expression you have, you put x as plus or minus 1, plus or minus 2, plus or minus 3, and so on. You can keep on checking for what value does this expression become 0. Listen to my words very carefully. I said you can keep on putting the values of x as plus 1, minus 1, plus 2, minus 2, plus 3, minus 3, and you begin from plus 1 and you check whether the value is coming 0 or not. If 1 satisfies this relation, I will say that 1 is a root and x minus 1 is a factor. Look at the difference between the two. I said if 1 is going to satisfy this particular expression, if I get the answer as 0, then 1 becomes the root and x minus 1. Observe carefully, the sign has changed. If 1 is the root, then the factor is x minus 1. If minus 1 is the root, then the factor becomes x plus 1. So factor is a what you can say, an expression which is going to divide this expression entirely. Root is a value which satisfies this expression. The value comes 0. So here if I put 1, I get 1 cube here. isn't it? 1 cube. 11 into 1, that's 11. So 11 plus 1, that became 12. X is taken as 1, so it's 1 square. You get 1 here, so that's minus 6 and minus 6. That becomes minus 12. So the answer is coming 0. Plus 12 and minus 12 definitely gives me answer 0. So 1 is satisfying this particular relation, this particular expression. So 1 becomes the root and x minus 1 is going to become the factor. So I'm going to make use of the synthetic division. So let's first of all write the question that is given to us. We have y is equal to what? We have y is equal to x upon x cube minus 6x square plus 11x and minus 6. So by synthetic division, I'm going to get the factors of x cube minus 6x square plus 11x minus 6. There are some rules that you need to follow. First of all, you check whether the given expression is having all the terms in descending powers, x cube, x square, x and then constant. If any of the term is missing, you can write it as 0, say x square. So 0 comes as the coefficient of x square if x square is missing. If x is missing, then you can say 0x. If the constant is missing, there is no need to write 0. What you can do is you can take out x common from these three terms. X is common, you can realize that the equation now becomes, or the expression now becomes a quadratic expression which can be easily factorized. So if constant is not present, don't write it 0, you just take out x common from the remaining three terms. So now let's make use of the synthetic division. The first rule is taken care of, all the terms are present over here, the terms are present in the descending powers. What is the coefficient of x cube? It is 1. What is the coefficient of x square? It is minus 6. The coefficient of x, it is 11, and the last constant, it is minus 6. Be very careful with the signs. You have to consider the coefficients along with their signs. Then students, what you can do is, your root was 1. If you remember, 1 has satisfied this particular expression. 1, when I put x as 1, it has satisfied the relation. So 1 has become my root. So I'll write 1 over here. Bring the 1 down as it is, isn't it? This 1 comes down as it is. So 1 into 1, that's 1. 1 multiplies with 1, you get 1. Minus 6 and plus 1, that's minus 5. 1 into minus 5, you get minus 5. 11 minus 5, that is 6. 1 into 6, that's 6. Minus 6 and plus 6, the answer is definitely going to come 0, isn't it? We were already aware that since 1 is a root, it is definitely going to satisfy the expression. So therefore, the answer, the remainder over here is definitely going to come 0. So now you can say this term, the last term, is a constant. This is the coefficient of x. This is the coefficient of x square. So therefore, I can say the factors of this expression, x cube minus 6x square plus 11x minus 6, can be written as, the root was 1, the factor is going to become x minus 1. And look at these three terms. They are going to be written as what? The coefficients are 1, minus 5 and 6. This is a constant. This is x. This is x square. So I get 1 into x square. That's my first term. The second term is going to become minus of 5x. And the third term is going to become plus 6. Getting on what? Now this is a very simple quadratic expression. You know that the factors, or you can say 6, can be written as minus 3 into minus 2, isn't it? Minus 3 into minus 2, you get 6, and minus 3 minus 2, you get minus 5 also, isn't it? So the middle term is arranged in such a way that you get the product with the last term, isn't it? The middle term is arranged in such a way that the product minus 3 and minus 2, when you multiply it, you are getting the last term plus 6. So minus 3 and minus 2, I can say the factors that you are going to get is x minus 1, and straight away you write x over here. Just write x with the minus 3, x with the minus 2. The factors become x minus 3 and x minus 2. You can cross check for yourself. X into x is x square, x into minus 2, that's minus 2x. Minus 3 into x, that's minus 3x. Minus 2x and minus 3x becomes minus 5x. Minus 3 into minus 2, you get plus 6. That's a quadratic expression. Very easily you can get the answers over here. So the expression that I had, x cube minus 6x square plus 11x minus 6, is now equal to what? It is equal to x minus 1 into x minus 3 into x minus 2. The better way to write this is x minus 1 into x minus 2 into x minus 3. So students, now this y becomes equal to what? It becomes equal to x upon x minus 1, x minus 2 and x minus 3. So it is now exactly same as the very first question, isn't it? So the solution for first question is going to be same from here onwards. So now students, you have x minus 1, x minus 2, x minus 3. There are three factors and these factors are non-repeated linear, because power of x is 1 everywhere. So these are non-repeated linear factors. So when you say non-repeated linear factors, nothing happens. Whatever is present in the numerator, it is not going to bring any consequence in your next step. Whatever the numerator is, just you need to take one care that the power of the numerator has to be less than the power of the denominator. That is more important. Any of the expression, even if you take x square plus 4x plus 1 in the numerator, it is still not going to make any difference to the procedure that I'm going to show you now. Just take care that the power of the numerator has to be just less than the power of the denominator. So how many factors you have? 1, 2 and 3. They are all linear factors. There are three factors. Simply bring three constants. So I can write this y as, so therefore y I'm going to write as, forget the numerator. Whatever it is present in the numerator, it does not matter. Just write a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. It does not matter whether there is one term, whether there are two terms, whether there are three terms, whether these terms are added or subtracted. It does not matter anything over here. Entire numerator simply vanishes. And you get a upon first factor, b upon second factor, c upon the third factor. Now I'm going to find the values of a, b and c. You'll be definitely getting the values of a, b and c. These values will be in such a way that when you simplify this particular expression, you will get back this original expression. So once you simplify this, you are going to go back to the original step. So I want to get the values of a, b and c. So here now I'm going to proceed with the partial fraction. So students, I am saying that x upon x minus 1 into x minus 2 into x minus 3 is written as a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. Now remember, your LCM here is the product of these terms. This is the LCM. So what you do is just imagine that this entire term a upon x minus 1, this entire term is simply multiplied with x minus 1, x minus 2, x minus 3. So x minus 1 and x minus 1 cancels. You will be getting x minus 2 and x minus 3. It's multiplied with a. Likewise, for b also, you do the exact same thing. Take this term b and you multiply with x minus 1 into x minus 2 into x minus 3. So this time x minus 2 cancels. You will be left with x minus 1 and x minus 3. And you carry out the exact same thing for the last term c as well. You multiplied with x minus 1, x minus 2 and x minus 3. This time the x minus 3 cancels and you'll be getting c into x minus 1 and x minus 2. So this method of LCM, you always remember, any question that I do, I'll be using the same concepts. So I can now say I get x upon x minus 1 into x minus 2 into x minus 3 is equal to. So what has happened? From the first term, x minus 1 has cancelled. So a multiplies with what? A multiplies with x minus 2 into x minus 3 plus b multiplies with x minus 1 into x minus 3 plus c multiplies with x minus 1 into x minus 2. And what was the LCM taken? The LCM was taken as x minus 1, x minus 2 and x minus 3. It's a very simple procedure. So whatever the LCM is, you multiply all the terms with that LCM and you simply divide throughout by the LCM. So from left and right, you can observe this entire denominator can be cancelled and you will be left with what? You will be left with, I'm going to write the terms in the reverse order. The right side comes left, the left side goes on the right, only for simplicity purpose. So a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. This is equal to, what is left on the left side? It is x. Is equal to x. So I'm going to call this as my first relation. So are you observing, it does not matter what is your numerator. If it is x, you write x. If it is x square plus 4x plus 1, you write x square plus 4x plus 1. If it is 2, you write 2. If it is again x, you just write x. So it is not going to matter what is your numerator. It just matters that the numerator should have power which is less than the power of the denominator. Nothing else. Just take care of that. So it does not matter what has come on the right hand side, isn't it? Now, who is your first factor? Your first factor is x minus 1. So, you say put x minus 1 equal to 0, or I can say x equal to 1 in equation 1. Isn't it? So just put x minus 1 as 0, or you can say x becomes equal to what from here? X becomes equal to 1 in this equation. So if x minus 1 is 0, x minus 1 is 0, x minus 1 is 0. So b into 0, it goes. C into 0, it goes. Isn't it? And what is x equal to taken as? It is taken as 1. So I get here a into, what is x taken as? 1. So that's 1 minus 2. You get minus 1. 1 minus 3. You get minus 2. X minus 1 are taken as 0. So b into 0, c into 0, isn't it? So b into 0 plus c into 0. What is x taken as? X is taken as 1. So I write here 1. So from here, can you say a is going to be 1 upon 2? The value of a has come 1 upon 2. Let's call this as the first equation. I've got a as 1 upon 2. Now let's proceed further for the next value. For the next value, who's the second factor now, students? Second factor is x minus 2. So now you put x minus 2 as 0. Therefore, x becomes equal to 2. Since x minus 2 is 0, you can get x as 2 in equation 1. So in this equation, you put x as 2. So what happens to x minus 2? It is going to be 0. So I get a into 0. What is x taken as? It is taken as 2. So x is taken as 2. You get 2 minus 1. So that's plus b into 1. What is x taken as? It is taken as 2. So you get 2 into minus 2 minus 3. So 2 minus 3 is going to become minus 1, isn't it? So that's 2 minus 1, you get 1. 2 minus 3, you get minus 1. Then plus c multiplies with, what is x minus 2 taken as? X minus 2 is taken as 0. So I get into 0 is equal to, what is x? The value is 2. So I write 2 over here. That means from here I can say minus b, isn't it? Minus b is equal to 2. So b is equal to minus 2. I'm going to call this as the second relation. And students, now we will proceed with the last one, the last factor, which is x minus 3. So I'm going to put now x minus 3 as 0. So let's put x minus 3 equal to 0. Therefore, x equal to 3 in equation 1. So when I put x minus 3 as 0, so x minus 3 I'm going to take as 0. So that becomes a into 0, and x minus 3 is again taken 0. So that becomes b into 0. So I get a into 0 plus b into 0 plus c into. What is x taken as? It is taken as 3. So get 3 minus 1. 3 minus 1 is 2. 3 minus 2 is 1, and x was taken as 3. So now can I say c is going to become 3 upon 2. So I call this as the third relation, isn't it? So I've got the values of a, b and c, students, isn't it? So now you can say that x upon x minus 1 into x minus 2 into x minus 3 can be written as a, which is 1 upon 2 upon x minus 1, plus b, which is minus 2. So minus 2 upon x minus 2 plus c, which is 3 by 2 upon x minus 3. And this is nothing but what? This is y, isn't it? What do we have? Y. Y is equal to x upon x minus 1, x minus 2 and x minus 3, which is now written as a upon b upon and c upon. And I've got the values of a, b and c. That means now I can say y becomes equal to, so what can I write? A upon x minus 1. So what's the value of a? It is 1 by 2. So I write 1 by 2 upon x minus 1. Then b has come minus 2. So this plus is now going to change to minus. So minus 2 upon, what do we have here? You have x minus 2, and finally plus c. So the value of c is 3 by 2. So plus 3 by 2 upon you have x minus 3. So students, I have got y. Do you recall that if y is equal to 1 upon ax plus b, then yn is equal to minus 1 raised to n into n factorial a raised to n upon ax plus b raised to n plus 1. You have to memorize this particular formula. I have already told you that this is the most important formula that we'll be using, and later on I'll be using 1 upon ax plus b raised to m also. So this formula should always and always be recalled. So you have y is equal to 1 upon ax plus b, yn is coming minus 1 raised to n, n factorial a raised to n upon ax plus b raised to n plus 1. So observe carefully, this x minus 1 is like ax plus b. Constant 1 by 2 does not matter, it simply goes outside the derivative. 2 does not matter, it goes outside the derivative. What is left again? Ax plus b. What is left here? Again 3 by 2 goes out, ax plus b. So all terms you can see that they are all ax plus b. So if I want to get the nth derivative, so I will say therefore differentiate n times. So we actually need not be differentiating n times. We have already got the standard formulas. I'm just going to make use of those standard formulas. So students, what is yn going to become equal to? So 1 by 2 is a constant. Very simply, I can take 1 by 2 is a constant, goes outside, and use this formula. You get minus 1 raised to n factorial. What is a in our case? Ax plus b. A is 1. So I again write 1 raised to n upon ax plus b, which is x minus 1 raised to n plus 1. That's the answer of the first term. Then take the second term, which is minus 2. That's a constant term, so it goes out. You have 1 upon ax plus b. So that's 1 upon x minus 2. You get the answer as minus 1 raised to n factorial. Again, you have 1 raised to n because a is again 1 here upon x minus 2 raised to n plus 1. That's your second term, isn't it? And the derivative of the second term and the final term. Again, you have the plus 3 by 2 as a constant. You now know the answer. It is going to be minus 1 raised to n factorial 1 raised to n upon this time ax plus b is x minus 3 raised to n plus 1. That's how you get the nth order derivative of the given function. So can you observe the entire solution that I've done over here, the entire question that I've solved? The major part was nothing but the partial fraction, and only one step I have made use of the nth order derivative. So it is a combination of the two different concepts that you have learned. You already know the partial fraction concept from the lower standards. Here you have learned how to find the nth order derivatives. Both the concepts are taken together and the question is solved in this way. So students, that was all about this particular question. I want you to try the rest of the questions.